All right. Hello and welcome to another episode of Containers from the Couch. In this episode, I'm excited to invite members of the EKS service team to talk about a recently announced feature for EKS on Outposts, local clusters. Let's go around the room and do a round of introductions. Sheetal, I'll pass it to you first.
Hi, I'm Sheetal Joshi. Many of you might already know me. I'm a senior developer advocate for the EKS organization. I'm glad to be here today.
Awesome. Chris?
Hey everyone, Chris Splinter. I am a product manager on the EKS team at AWS, and I focus on our hybrid and edge solutions.
All right. Last but not least, Lior.
Hi everyone, I'm Leo and I'm a senior software development manager and I run the engineering team for this new feature that we're going to talk about today.
All right, so we've got a spread of folks from the EKS service team today. We've got engineering, product management, DA today. We're excited to talk about this new feature, but first, I think we need to take a step back and understand where the need for local clusters even comes from. And I think that starts with hybrid. And so we know that millions of customers using AWS today to lower costs, be more agile, innovate faster. Along that journey, they find that there are specific workloads that may need to run in on-premises, hybrid edge environments. And so first, Chris, let me ask you a question. Talk a little bit about some of these use cases and why customers might need hybrid capabilities for running EKS.
Yeah, it's a good question, Sai. And as you said, there's a lot of different applications and use cases that are able to run in the cloud. I think it's the majority of applications in the long term will end up being able to move to cloud infrastructure. But we work a lot with customers in telecommunications, in healthcare, financial services, some manufacturing applications, and they have unique requirements either around low latency, local data processing, regulatory reasons. Sometimes they need to keep certain data within national borders. And so these are really the common themes that we see across these different industry verticals that kind of drive their use cases to remain on-prem, both now and, years into the foreseeable future.
Right. So you mentioned a few things there. So low latency workloads. So for example, if you need to run workloads somewhere and maybe there's not necessarily an AWS region nearby, some workloads that need to run locally, for high volume throughput or data processing considerations. I think there's quite a few, but those are probably some of the trends that we're seeing with customers today.
Now, yeah, I think one more that I didn't mention that's definitely important to call out, like a lot of customers are on-prem just for historical reasons, right? It's where they've started, they have existing hardware investments, and they're not ready to get rid of that yet. And I think that makes a lot of sense as well.
Right. So in that modernization journey and somewhere along that path, it's not always as simple as moving the workloads over to the cloud. Sometimes it needs to happen piece by piece. Now, to help our customers make that transition, I know EKS offers a number of solutions for hybrid. I know today the focus is, EKS on Outposts, but what are kind of some of the other components or capabilities that customers could use?
Yeah, and generally what's driving our strategy is we want to enable customers to run EKS wherever they need it. So if we're in, primary data centers that are highly connected to the cloud, if we're in data centers that aren't connected to the cloud, if we're at the edge, we want to give customers that consistent operational experience across all of the different places that they need to run their applications. And so our two primary offerings today in the hybrid and edge space are EKS on Outposts, which you mentioned, and also EKS Anywhere. And when we talk to customers about well, what's the difference? When should I use one versus the other? It really comes down to three factors. And the first factor, we always start at the infrastructure level. If customers have existing infrastructure that they have to use, whether that's with VMware or bare metal, then EKS Anywhere is really the best option because EKS Anywhere is a AWS supported Kubernetes offering that customers can run on their own hardware. But if customers are able and open to invest in new infrastructure, then that's typically when we start the Outpost conversation where If they're running in a data center, we have 42U racks, or if they're running at the edge, there's 1U and 2U servers. And so we always start the conversation at that infrastructure level, and that really kind of helps us navigate the EKS portfolio between the two options.
Got it. Got it. And I know we've talked about EKS Anywhere a few times on this channel, more than a few times, and EKS on Outposts a few times as well. And I just posted a video in the chat as well if folks want to quickly understand how EKS Anywhere versus EKS on Outposts, how they're similar and how they differ. Now, in that video, which was released a little while ago, earlier this year, I talk about how for EKS on Outposts, we use something called an extended cluster architecture. And now with Kubernetes, I think it's important to understand there's two primary components, right? There's going to be the control plane and the data plane. Of course, there's a lot more, but I like to split it up into those two. And in that video, I talk about how EKS on Outposts requires that you run that control plane in the cloud, public cloud, the parent region connected to your outpost, and the data plane running on premises on the outpost itself. But that's changed now, right?
Yeah, so with the model that you're describing, the extended cluster model, with the Kubernetes cluster split between a region and the outposts, you can run into some interesting behaviors when the service link that connects the outpost to the region goes down. And if there's folks on the call that like diving into the code, you can look at the node lifecycle controller that literally has 7 different configuration options that affect how your cluster and workload will behave when that service link connection goes down. And so in order to really take that network, that wide area network failure domain out of the picture, we created a new deployment option for EKS on Outposts that we call local clusters. And one of the primary benefits of that new feature is that even if the wide area network service link connection between the outposts and the region goes down, that cluster is going to continue to run, and you can continue to access your cluster over your local network and issue Kubernetes operations against your Kubernetes API server that's running locally now with local clusters.
So Chris, just to level set with our audience here, I know you work closely with customers often. Realistically, what sort of events are we talking about that could cause a disconnection between your outposts and the cloud?
Yeah, and it's a great question, and I want to emphasize that we built this feature for temporary network disconnects between the outpost and the cloud. Outpost still remains a fully connected offering. And so if you do have to run in a fully disconnected or primarily disconnected mode, that's another factor where you'd want to consider EKS Anywhere. But for the types of network disconnects that we see and that customers are concerned about, they can be because of weather events that knock out a line, or they can be because a fiber was cut for whatever reason. Maybe there was some construction going on, or even misconfigurations on the network between the outposts that has the route back up to the service link is another reason for concern that we've heard from customers.
Got it. And we're seeing some comments come through in the chat. OneComeG says having universal deployments that I can apply in different environments is very interesting. Well, we've got a treat for you today. Sheetal and Lior are going to be going through a demo where we're going to be outlining exactly how local clusters work. And for your second question here, can you describe how the recovery would work in the event the WAN restores? So we'll go over 2 scenarios, actually 3 really. It's how the disconnect affects the environment, as well as when that connection is restored. So be sure to stick around to watch this demo. And in fact, now that we kind of have this rough understanding of exactly how local clusters for EKS on Outposts work, let's pass it to Sheetal, who I believe has a demo that she's got for us today on local clusters.
Hey, hi. Sai, do you want to bring in the slide deck before we get into the creation of the cluster itself? Let's walk everybody through the prerequisites that are required to create a local cluster.
Yeah, let's do it. So here we've got kind of a rough overview of the kind of architecture with local clusters. We'll pass it to you, Lior.
Right. So in this slide, we have a notional architecture where on the right side, we can see the customer data center with an outpost configured. In a customer account, we have a local gateway to enable traffic going from the customer on-prem network and data center to the outpost and vice versa. And we have a private subnet hosted in the outpost. We have a route table associated with the private subnet with an entry to enable traffic towards the local network using a feature called direct VPC routing, and another route to the NAT gateway in a public subnet on the left side, which is hosted in the region. This, coupled together with an internet gateway associated with the VPC, enables traffic to the internet, which is a requirement today, as of now, for local clusters to be able to access different AWS services that we need during cluster creation and monitoring of existing clusters. Soon we'll be launching support for fully private clusters, so stay tuned for more announcements on that. This configuration enables outbound internet access and prevents unsolicited inbound connections from the internet. In fact, local clusters work very much like any other resources on AWS Outpost, which are deployed into the Outpost using the subnet you provide during cluster creation. You essentially extend the VPC and the subnets from the parent region to the Outpost. If we can go to the next slide now, please. Hi. So in this slide, we have a general guideline for capacity planning. Local clusters, such as pretty much everything that goes on in a local data center, requires some level of upfront planning. We use 3 EC2 instances to host the Kubernetes control plane, which we'll talk about in detail soon in the following slides and in the demo. We use these 3 instances to build a local cluster in a highly available configuration. And when planning for your cluster, you can use this rough guideline that's also available in our public documentation that maps intended number of worker nodes to an instance type or instance size for the Kubernetes control plane. So for example, if you plan on having 50 worker nodes, you may want to go with an extra large instance type, such as an M5D large, extra large, sorry. In addition, each local cluster will consume 246 gigabytes of EBS storage, which is mainly due to etcd performance requirements. All of the numbers you see here are the result of extensive testing we have run prior to launching this feature. But take it
so Lior, there's one thing I wanted to kind of point out here. So Chris kind of introduced the concept of this extended cluster architecture versus local clusters. And we know that with local clusters, we need to do some capacity planning because you're running not just the data plane, the worker nodes where your containers are running, but also the control plane. Whereas in the extended cluster, the control plane would be running in AWS public cloud. And so I guess what we're seeing here is that result of your testing to show that, hey, that there is really a trade-off to consider here. And with local clusters, there is some compute that's going to be required on premises to kind of maintain running that control plane. Now, for these numbers themselves, are we going to see this as kind of like a steadfast rule, or how can a customer really take these numbers and apply it to their own scenario if they're considering running a local cluster on Outposts?
So again, take this as a rough guideline based on testing that we've done. With local clusters, you need to do some upfront planning for the extreme use case or the worst case scenario. What happens when disconnection happens? How does that affect your use case, if at all? Different use cases, if it's a telco environment or banking, financial systems or whatnot, have different requirements in different scenarios. So some of them may have an upfront foreseen uptick in usage during a period of disconnect. So we recommend planning for that uptick in capacity upfront. And when you do that, that number of worker nodes come into play. Obviously, there's a lot more details into Kubernetes because the overall load on the control plane is affected by many different other moving parts. So again, take this with a grain of salt. This is just a rough recommendation to get you started.
Got it. Now, we do have a question in the chat, Lior. Presumably, the physical deployments on Outpost need to factor in necessary fault tolerance for hardware?
So Outpost itself got redundant devices if it's network interfaces and networking devices, and transport links back to the region come in redundant forms. There's a full-on documentation in the Outpost public documentation to describe how to set up fault-tolerant configurations for Outposts.
Absolutely. And in many ways, I've seen this analogy said before, Outposts are really considered an extension of an AWS region. So, what we see here is that prerequisite architecture of the infrastructure that's needed. I think this is going to lead into the demo that Sheetal wants to show. So we've got that VPC that extends not only from the public AWS cloud, but into the customer data center. We have a private subnet there in the customer data center as well. Now, there's a few components here that we kind of quickly covered. I think, Leo already covered the internet gateway, the NAT gateway, the local gateway, lots of gateways here. But I think this will all start to come together a little bit better once we see the actual cluster get created. So Sheetal, I'm going to pass it to you now. Looks like you're ready to start the demo.
Yeah, I think before I start off the demo, I just want to make sure on that capacity need. I guess it's only those 3 additional CPI instances what you need to plan for, right? Like when in an extended cluster scenario, you will anyways plan for the number of the worker nodes, the types of the worker nodes per your application and your use cases. But here, those 3 extra control plane instances that you need to accommodate on your Outpost hardware.
That's right.
Yeah, cool. So let's see now. I am on EKS console. I have a few clusters already provisioned here. Let's go ahead and try create a cluster. So if you have AWS Outpost that is provisioned in your account, you would see this AWS Outpost option appear when you click on create cluster. And Outpost, whatever Outpost that has been provisioned, you'll be seeing those in the dropdown. I'm going to choose one of the Outposts here. As you can see, the replicas have been hard-coded to 3 because that's what we support today. And also the instance type has been pre-populated. So the Outpost that I'm using for today's demonstration is only been slotted for M5D large, and that's what you're seeing here. So I'm just going to...
Sheetal, one question here. Sorry to interrupt you. You're in a good flow here, but I just want to level set a little bit for our folks viewing this. For me, this looks like AWS Cloud. And if I look at the URL, it says US West 2. So you did mention you're working within an Outpost being infrastructure that's on premises, not in an AWS data center. And so I'm looking on the top right there. It looks like it's your username at den80 Outpost. So what exactly are we looking at here? Let's kind of level set a little bit.
Yeah, all great points. I'm just going to be talking about those. Let's finish up filling up these details, and then I'll talk about the Outpost when we start configuring the VPC and the subnet. Yeah. So what you specify here is the name and the Kubernetes version 121, and 121 is what we support for local clusters as of today. I'm just gonna choose the role. I have the role already created, and this role allows Amazon EKS to manage AWS Outpost resources on your behalf. So on the next screen, you will see the VPC. And let's look back at what Sai was trying to mention, right? So I am on US West 2 region here, and it all starts with the subnet and an Outpost configuration. Basically, the subnet that you're seeing here is called as an Outpost subnet because that has been associated to Outposts that I'm going to be creating clusters in. And what you see here on the right-hand side is just my account, right? It's not like specifically an Outpost account, but this account has Outpost provisioned in, and I have, the rights to access those Outposts. Yeah. So.
And we actually got a question in chat here. I want to feature that really quickly here. So to configure Outposts using IAC options, is that possible? For example, can you use Terraform to work with AWS? So I'll say one thing really quickly, and then maybe I'll pass it to one of you to add some detail. But I really do see EKS on Outposts very much the same as EKS in the sense that you can use AWS to manage that environment, and including using the EKS APIs. and that also means you can leverage tools like Terraform as well. Is that fair, folks? Am I right there?
Yeah, so EKS on Outposts, it is the same EKS that you run in the cloud, including the APIs, all of the interfaces, AWS CLI, EKS Cuddle, Terraform included, CloudFormation. And so you can use all of the interfaces that you typically use with EKS in the region with EKS on Outposts.
Yeah, and Chris, if I'm not wrong, we also added support for EKS blueprints as well, right?
I think that's still TBD, but it's coming soon.
Yeah, okay. Yeah. So the short answer, yes, we do support all of the IAC options, and the APIs that are supported for creating EKS in region are applicable to EKS on Outpost as well.
Yeah, and in fact, even looking at this experience itself, it's very reminiscent of EKS. It's kind of built into the same platform, and again, like I mentioned, you look at the URL, you can see it's connecting through the parent region at US West 2, although it's configuring the infrastructure that's running in the Denver on-premises data center.
Yeah, and that's really the benefit of not just EKS on Outposts, but Outposts in general, is you can use the same AWS services that you use in the cloud on-prem.
Thanks, Chris. All right, Sheetal.
Yeah, so I just chose the VPC that we have extended to the Outpost that we are using for the demo, and just using the subnet that I just showed here. You can choose more than one subnets, and necessarily all these subnets have to be mapped onto those outposts. Otherwise, you will see an error. Make sure the subnets that you're using to create your clusters in are outpost subnets. I chose the cluster IP address family IPv4, and only IPv4 is supported for local clusters today because IPv6 is not supported on Outpost yet. We support only private cluster endpoints for local clusters for all the security reasons, and all the worker node traffic to this endpoint will stay within your VPC. Let's go ahead and create this cluster. I'm just gonna enable logging for any debugging later. Yeah, click create. So while this cluster becomes active, I'll pass it on to Lior to talk about cluster architecture in detail and how EKS actually manages these local clusters on Outposts.
Thank you, Sheetal. So a bit of a deep dive into the architecture that runs behind the scenes and powers local clusters on AWS Outposts. When creating local clusters for extra security, we chose to use Bottlerocket as the base AMI-based image operating system for the control plane instances running on the Outpost. And we're also using Systems Manager, SSM, to securely connect the local clusters management service in the region to the control plane instances on the Outpost for the purpose of health monitoring, patches and upgrades, and the entire management offering. In this slide, you can see a bit of the details with regards to the architecture. On the right side, the Outpost, a private subnet, contains 3 EC2 instances that holds the control plane components of the Kubernetes control plane. And if we go to the next slide, we can have a deeper look at the details there, where we see the 3, again, different instances hosting the different components for the Kubernetes control plane, the API server, the scheduler, the controller manager, other parts that we got running, and etcd. This is what is called a stacked configuration, where each node has its own etcd instance, but all of the instances are interconnected with one another using static IPs for, again, achieving that highly available configuration in a redundant manner. This also enables us to deploy patches and upgrades with 0 downtime to the cluster from the region. In the next slide, we see that in order to connect from the management service in the region to the control plane instances on the Outpost, we use SSM again. SSM provides a secure abstraction layer to enable us to connect to pretty much any EC2 instance type with a supported AMI version and type that runs on the Outpost EC2.
Got it. And so if I quickly jump back to the previous slide, just to kind of circle this back to what we talked about with control plane node sizing. So essentially what we're saying is that due to the stacked kind of layout here, or even if we weren't using the stacked setup, as we add more and more worker nodes that are being managed, we will also need to increase the size of each of these nodes to handle being able to effectively and with high availability to manage those worker nodes, right?
So again, that goes in part with upfront planning for your cluster. Outpost is a physical hardware device that comes pre-slotted per your desired configuration. So that all goes into that upfront planning where you plan for the number of instances, the number of worker nodes, the type of application, and your anticipated traffic throughput that you foresee with those applications and services that you're going to service from the output.
Got it.
Yeah, and one thing I just want to clarify, I see a few of the questions in the chat here. From a user experience standpoint, all of your cluster management actions, so create cluster, list clusters, describe clusters, delete cluster, those all hit the endpoint that's running in the parent AWS region. Your Kubernetes commands that you would issue via kubectl or some other automation would go over the local network and to the API server, the Kubernetes API server that's running on the Outpost. So I just wanted to clarify that from a high-level architectural standpoint.
So we can kind of see that in this diagram, right? So the user that's working with this from the customer data center, you can see when they do things like creating a cluster, that still goes to the parent AWS cloud region. And you can see that horizontal line going to the left there for the create cluster command. There isn't a line here going directly through the local gateway, but you can kind of imagine if you're operating directly against the cluster, that communication will go through the local gateway. And I think in a few minutes here, we're actually going to cover that disconnected scenario, which will actually go through that exact flow. So, Lior, was there anything else that you wanted to cover on this particular slide with SSM?
No, I'm good.
Cool. All right, Sheetal, we're going to jump back to you here for the next part of the demo.
Yeah, so you can still see the cluster that I created before is still creating. So let's use the cluster that have already provisioned just before the start of this session. So what you're seeing here is a local cluster, which is in active state. So let's look at the compute tab. So unlike your EKS clusters in region, you will also see all the control plane instances being listed here and which are in not ready state. And this doesn't mean the cluster is active. It's just that these instances, control plane instances, have been tainted for not scheduling any workloads, and that's why the state is not ready. And also you see additional 3 nodes. These are all the worker nodes. Local clusters, we only support self-managed node groups today and not managed node groups. So I have a cluster and then worker nodes already added and ready to go to deploy some apps. So I'll switch back to my terminal window here. Just gonna connect to the local cluster. Let's see what are the pods that are already running on the cluster. So what you can see here is there is a VPC CNI, which is AWS node already running. Core DNS is up and running as well, along with the kube proxy. And this is something different that you might, whoever have been used to logging into EKS clusters in region, you will see much more than just these 3 add-ons being provisioned, like in API server, the etcd endpoints, the certificate controller, along with controller manager as well. So these are all the pods that are running on the control plane instances. And again, we do not support managed add-on as of today. These are all self-managed add-ons. I did provision load balancer controller as well. We are gonna deploy an application with an ingress endpoint. AWS Outposts today support application load balancer, and that's why I'm just gonna use Kubernetes resource type ingress. And like as and when Outpost adds support for the network load balancer, you should be able to automatically use the Kubernetes type service and the type load balancer. So let's just look at the sample application here. It's just a sample web server that I'm just running, and you can see a Kubernetes ingress type and with all the right annotations basically. So I'm just going to deploy an internal load balancer with a target type as instance. And you have to make sure that you are passing in the subnet, and this subnet has to be an Outpost subnet. If you forget to pass in any subnets, then it's just gonna use the subnets that are properly tagged, and that might land up on the subnet that's in a region and not an Outpost. So let's go ahead and deploy this.
So while you're deploying that, Sheetal, I had a question here. So you showed how we can expose the application using a load balancer, an ingress. Now, that's through the application load balancer, the add-on that we have. Now, what about for exposing applications with a service type load balancer, an NLB? Can you talk about the difference between using an ingress versus which is ALB, or a load balancer service type, which is NLBs?
Yeah. Basically, you can expose applications in many different ways, right? And one way is to expose this application as Kubernetes ingress type, and another is a service. And as service, there are 3 different types that Kubernetes services comes in. And when you use Kubernetes service type as load balancer, the AWS load balancer controller that is running on the cluster provisions a network load balancer, and you will access your application via the network load balancer.
Now, but this is not an approach that you can take advantage of with the local cluster architecture, right? And I think this is something.
Yeah. So you will not be able to use Kubernetes service type of load balancer. However, if you do not have any use case of exposing these applications outside of your cluster, you should be able to run these services as node port services. Yeah, that should be just enough. Yeah, not all of the services need to be exposed outside of the cluster. Then you do not have to. And if you still require to access these Kubernetes services, you can make use of something called as direct routing. Chris, correct me if I'm wrong, but when you have the direct routing enabled, you will be able to access basically all of the worker node instances from your on-prem network, and you can still use the Kubernetes service type node port service.
Yeah, and just to add another comment on top of that. So there was a new feature released for Outpost racks called direct VPC routing. And with that feature, the private IPs of the private VPC IPs of the instances that are running on the Outpost are automatically added to customer-owned IP pool. And so we also integrated with that ALB's integrated with it, but so is local clusters for Outposts for the Kubernetes API server IPs.
Got it. So using that approach, you could potentially leverage maybe your existing load balancing solution to expose applications without going through the ALB approach, is how I understand it. That being said, Sheetal, I see in the demo you've got here, I'm seeing congratulations. What are we looking at here?
So I'm just trying to call my ingress endpoint, right? The load balancer endpoint, and you see application is up and running. Yeah.
So what we saw here was you created that ingress YAML, and so the AWS load balancer controller was able to dynamically create this address for us using that ALB that's running in the local cluster environment.
Correct. And the behavior of the Elastic Load Balancer controller doesn't change with the local cluster. It's a similar behavior. Depending on how you have configured your ingress, whether IP or an instance type, the load balancer target group is going to be getting updated accordingly. Like if you have configured it as an IP type, then all of the pod IPs will be listed as targets for that application load balancer. Yeah, so it's a similar behavior as in the region. Let me see if I can show the load balancer.
And Sheetal, did you talk about how the fact that the Kubernetes control plane instances are configured with static IPs?
I did.
Okay. Yeah, I just saw a recent question about the DNS working in the event of WAN isolation.
Yeah, so what you're seeing here is just the load balancer as I was pointing to, right? And if you see the listener and the target, basically you will see these are my worker node instances that are being registered as targets.
Got it. Very quickly, Sheetal, I do want to raise a question that came into the chat that Chris just referenced. So how would DNS work in the event of WAN isolation?
So let me show. Yeah, Leo, do you want to come in?
I think you had touched on this a second ago.
Well, it has a few aspects to it. First of all, with regards to the internals of the control plane working, we use static IPs to configure the connectivity between the API server component and etcd component. However, the private endpoint for the cluster service itself is hosted in Route 53 in the region. Again, with the local clusters, and especially when talking about disconnected scenarios, some form of upfront planning is required, and we assume that customers have their own DNS or otherwise equivalent solution running in their data center. So you may want to publish that record for the API endpoint in your local DNS as well.
Right, and this might be a good time to quickly talk about how that connection to the cluster endpoint actually occurs. So a couple of questions about this pop up in the chat. There was a question around, or rather a comment answer to a question about pointing your AWS CLI to your Outpost endpoint using custom service endpoints. Lior, do you want to quickly walk through that flow of how that endpoint is resolved in this connected scenario using Route 53?
Yeah, so the AWS CLI does not need to be pointed into anywhere specific or special for accessing resources on an outpost because you basically call the specific AWS API, in this case, the EKS API, and you give it the relevant parameters to the specific API you call. In this example, when you call create cluster, there's an added parameter that's called outpost config block, where you add the outpost ARN and the subnet which is associated with the outpost, and that instructs the EKS API and the management service behind the scenes to instantiate or create and provision the cluster on the outpost itself versus as it normally would in the region. But other than that, the AWS API itself does not need to be pointed to an Outpost endpoint. The kubectl command needs to use an updated kubeconfig. So normally when you create an EKS cluster in the cloud, once the cluster is created, you call an EKS API called update kubeconfig, and that creates the kubeconfig entries locally on your workstation, which holds the certificate authority details and the cluster endpoint. And you would do the same thing here. It also creates mapping for RBAC, role-based access control, which uses by default IAM, the IAM service to authenticate the caller against the API server. So in a normal state, as you would see in this slide, there's a line going from the user to Amazon Route 53 to resolve the endpoint for the API server. And then the API server goes back to IAM in the region and STS to authenticate the caller against its known and approved callers upfront. That's all fine and dandy in a connected scenario. However, local Outpost was built specifically to address disconnected scenarios. So what we've done, if you can please switch on to the next slide, we've also added support for X509 certificates. So again, during connected times, you need to prepare for this. The documentation contains instructions on how to create and sign an X509 certificate, which you can then download to your local workstation and store in a safe place. And then when you're disconnected, you have an updated kubeconfig entry, which uses X509 certificate. And so when you issue kubectl commands to connect and operate on your cluster in Outpost, it does not call IAM in region to authenticate your calls, but rather uses the local certificate controller to manage and authenticate your calls. So you can continue operating the cluster normally throughout the disconnection period. With that, we can go into the next slide and talk a little bit more about disconnected experience. When we talk about disconnected, we actually distinguish between two different terms: static stability, where the cluster simply continues to run, and continued operations, which enable customers and users to perform mutating functions on the local cluster. With static stability, customers can use alternative authentication mechanisms for disconnected state, as I mentioned before, the X509 certificates. And you can also configure your local DNS with the static IPs for the Kubernetes control plane instances. And you're also able to troubleshoot any issues you have with your local Kubernetes cluster using native Kubernetes /metric endpoint to access the logs. You can also install Prometheus in the front end and Fluentbit and other tools that you would normally use with any standard Kubernetes cluster. All of that should continue to work normally during periods of disconnect. For continued operations, if you plan on needing to scale up your workloads, your applications during periods of disconnect, again, you need to plan for it upfront. If the container images that you plan on using are not cached locally on the Kubernetes cluster, you may want to use a local container registry so that you can create or update or push new versions and scale applications that do not use EBS volumes, because EBS is not supported throughout disconnect. And you can even pre-provision spare worker nodes and have them join the cluster up front during connected times, so that if you need to scale up your applications, you've got those worker nodes standing in idle and waiting to be used. So all of that is a bit different than what you normally expect with a dynamic cloud environment, but this is the nature of a local data center where you need that upfront planning and design to come into place.
Got it. So, Lior, the way I hear you talk about this, and I, Chris had mentioned this in the beginning as well, that really this is a feature that was designed for temporary disconnects in mind. And even when you talk through this experience, there's a few caveats, some pre-planning, some things you need to do ahead of time to make sure that in the case you disconnect, there's certain things you can do, that static stability and that continued operations. But this is not realistically an experience you would want to be in long term, right? I mean, you're really working in a stopgap prior to getting the connection restored.
Yes. So we've tested it throughout a relatively long period of disconnect over a few days. And we've planned for caching the local logs on the Outpost during those few days of disconnect. And once you reconnect, we push those logs back to the region for you to use in CloudWatch and other services that you would normally would. But you're right, this is planned for a temporary period of disconnect, not indefinitely.
Got it. So this experience that we just saw, I know we had mentioned we wanted to actually show this experience. Sheetal, are we ready for the last part of the demo here for the disconnected experience?
Yeah. I think we see questions regarding the same. So do I change the context in kubectl in a disconnected state, right? So yeah, just hold on. We will be.
We're about to get to it.
Yes, exactly. Yeah. We are not gonna do like a hard disconnect just for the sake of it. What I'm gonna show here is just simulating a real disconnect. Just gonna update the security group to.
So you're saying we're not going to go to the Denver 80 data center?
Yeah.
fiber?
No one here on the call are in the Denver data center today, so we are not going to go ahead and unplug something at the switch level, but just I'm going to do a soft disconnect. Yeah, you just saw me removing a security group which allowed outbound access to the internet. Just going to go ahead and save the rules. So all this time I was just using the kubeconfig that I actually downloaded after the cluster was created, right? And I was able to connect. To connect to your cluster during the disconnected state, you need to generate a kubeconfig, right? And this kubeconfig leverages the XO59 certificates that Leo just talked about. So let me just show you actually how this certificate creation works, right? While you are disconnected, all of these steps are available today on our EKS user guide. So it's just a snippet of the commands that I run to create an admin kubeconfig to use for any of the kubectl operations. And these all are the steps that you perform while you're still connected to the cluster. So I have a admin kubeconfig that I have created. I'm just going to go ahead and change the context to basically use this admin kubeconfig that I have created. So let's go ahead and see if I am able to connect using the regular. Yeah, as you can see, I'm not able to connect to the cluster anymore. It's in a disconnected state. So let's use. So this is the cluster state. You can still have the static stability of all of the applications that are previously been provisioned and running. So the sample applications that I deployed during this call are still up and running, and you can use the admin kubeconfig to connect to your cluster and perform any of the application scale and update operations.
Right, and as I think Leor had mentioned this, if there were one of these pods that was pulling a container image from ECR and public cloud, if we were to restart that pod or update that pod, then it actually wouldn't be able to pull that image, right?
Not necessarily. If you are just trying to restart a particular application and if that image has already been cached on your nodes, that would still work. I'm just going to deploy a complete brand new application wherein that image has not been cached on any of these worker nodes. Then you will see error image, back of error actually. So let's go ahead and deploy a sample app, totally a different app altogether.
Well, that's not going to work right now, right? Because the config.
Yeah, I just have to. This should apply. I'm just going to use a complete different manifest to. Excuse my fat fingers here, but yeah, if you just go back and observe, I think. Yeah,
I'm guessing you've already deployed that app before.
Yeah, I have already deployed this app before, and that's the reason. I should be able to use a different one that I have not deployed before, but this app has already been deployed. So that indicates that the image was already cached, the container image. So that's where it is able to run. Yeah.
Gotcha. And we did get a question now, doesn't the need to pull images depend on my manifest? So if I don't always pull new images, I should be okay. So answer is yes. Sheetal, you want to add some detail?
Yeah, if you had pulled that image and that image is available on your worker node, that should, continue to work. Yeah.
That's right. It's really only when you're deploying a new application. And even then, if you wanted to, you could deploy a local container registry to this cluster and pull directly from the local registry. And that should be fine. as well. So there's ways to kind of, serve stopgap solutions for when you're in this disconnected environment.
That is correct. And
Sheetal,
Leo,
how did the actual X509 certs, maybe I had missed this, but when did we generate those certificates, and how are we using that in the kube config that you passed in?
Yeah, so I have generated this X059 certificates and also the kube config file before the start of the session when I was still connected to the cluster, right? And let me go ahead and open up the kube config file here. And the certificate data that you see here is from the X509 certificate that I have generated. Yeah.
We just have to remember to delete this and refresh it after the demo, right? Unless someone actually wants to go and type all those letters down and access your software.
No, yeah.
Was there a sequence of steps, the steps that you had referred to that you had ran before when you were connected? Is that something that you can show us?
Sure. The steps that I'm sharing here are also available on our user guide, right? So what you do is basically you go ahead and create the certificate request, and then you approve that and create also the roles for the admin user. And it not always necessarily have to be an admin, but you just create search for different users per your application personas and the use cases, like different operational personnel, different applicational personnel that you have. You might want to create different certs for each of these personnel, and do not want to keep distributing the same certs to everybody. Yeah, and also just for the demo, we are just adding it as an admin and to the system masters, but not necessarily he has to belong to the masters group. Yeah.
So in general, I guess my webcam just disappeared here. So now, in general, Sheetal, I just wanted to quickly understand here. If you wanted to actually do this in best practices, live conditions, you would want to be regularly generating these certs in between while you're already connected, right? So in the case that you were disconnected, you have unexpired certs ready to go.
That is true. You might want to build in some kind of an automation that you are generating these and distributing these certs regularly, so that in any case of the data theft, you are not compromised, right? Yeah, that's the automation mechanism that you need to plan for. And we are working towards making this entire experience simpler. And Chris might want to talk about it, but you will see in the coming months or maybe in the coming quarters that you do not have to basically execute all these steps, right? We pre-provision a cert for you, and then you can download and use that certificate to create other certs and kube config files for your personal on your side.
Yeah, TBD. If anybody has feedback about the experience with these certificates, we'd love to hear it. We're very much still defining the experience for it. So yeah, as always, the containers roadmap GitHub is a great place to go to put in your request, and we monitor that all the time.
And I've dropped a link to that in the chat as well. I do want to, Chris, give you a few minutes here to talk about what's maybe on the roadmap, something you're excited about that's coming out for EKS on Outposts, maybe specifically for local cluster support. But before we do that, Sheetal, I wanted to make sure, is there anything else that you wanted to show us in the demo today?
No, I think that's all for today. Like I would suggest, like all the viewers here, if you have an outpost on your on-prem environment and have an access to one of the outposts, just go ahead and try these. And as Chris mentioned, please feel free to leave your comments in the form of the issues on the containers roadmap. And if you want to see if anything that might help you to basically get started.
We just had a question come in. Can we use ACM for cert management? Now, I'm not sure if ACM is on Outposts and the exact architecture, but I'd imagine if you're losing a connection to AWS Cloud, you probably don't want those certs to be running and stored within AWS public cloud. You'll likely want to have those locally, so you have them available for when you want to connect.
Yeah.
Is this a use case that's come up before?
Yeah, and I mean, it depends how you're using ACM. The short answer is no, you can't use that today, but that is kind of exactly what we're looking at. Like, how do we enable you to bring your own certificate authority so that if you're using ACM, great. If you're using HashiVault, great. If you're using, I don't know, anything else, great. But that's something that what I was talking about before in terms of we're still collecting requirements and scoping out the customer experience. If you have feedback, like, please do reach out to us because we'd love to hear it.
Chris, anything else you want to share that's maybe on the roadmap, or maybe how folks can get in touch? Anything that you're excited about that's coming down the line?
Well, I'm always excited. I stay excited, but no, I mean, KubeCon's on our roadmap in a few weeks, so we'll all be there. Hope we can see a lot of other folks there as well, and a lot of the new features that we're going to be announcing are going to be in various AWS Container Day sessions, and so the one thing I would say is everybody should just try to attend that, try to join us either virtually or in person, and it'd be great to meet some of the folks.
Plan. I just pasted a link in the chat as well. If you want to see what we're doing in Detroit, it's in about 2 weeks now. If you want to see what AWS is doing in Detroit for KubeCon, we have a container day on October 25th, as well as 3 days at KubeCon where we're going to have a booth. We're going to have booth sessions the entire time as well. So be sure to stop by, grab some coffee, talk to one of us there if you're going to be there on the ground. Now, last things here, we have just a few more minutes. If you have any questions or comments, feel free to drop them in the chat. We did get a question about, is there any blog for the session with commands and steps? You're in luck. Actually, one of our speakers today, Sheetal, does have a blog on local clusters. In fact, a tutorial as well. I'm going to find a link real quick here and paste it in the chat so you can kind of follow along with that.
Sai, I think we should also upload the Terraform and the CDK and the API links as well to the comments later.
Yeah, definitely. So I'll make sure that we get those added in there as well. And I'm dropping a link to Sheetal's post on local clusters now. All right, folks, thanks so much for joining us for this episode of Containers from the Couch. And thank you so much to my guests today for that in-depth tutorial and demo. Be sure to subscribe to the channel and tune in for next time we do a live stream on Containers from the Couch. Thanks for joining.